can win.
All right.
Hello.
Yes.
Hello, yes, ma'am.
हा सर आवाज येतोय का?
Yeah.
कोरे सर.
Yes,
Am I audible?
you are audible now.
Yes, madam. Yes.
Okay. Can I mute or unmute on my own?
Yes, madam. Yes. Yes, madam. Yes. You can mute and unmute on your own.
Okay, sir. Okay, fine. I joined as an attendee.
त्याच्यामुळे राहिले ते
Yole madam, can we start?
Yes, yes. Can we start the session?
Yes.
Good morning, one and all. I am Mrs. Dipali Evle from AISSMS IIT. Welcome you all for the webinar on the topic Artificial Intelligence in Agriculture, Present Applications and Impact. I request our beloved principal sir to say a few words and inaugurate the session.
Thank you, madam. A very good morning to all the participants. First, I would like to take this opportunity to welcome Dr. Sarang Nerkar, who is our expert today for this session. Welcome, sir. Secondly, I would also like to take this opportunity to thank KVK and Agriculture Baramati for being the co-host and also giving us an expert like Mr. Sarang for hosting this webinar. I just want to brief as to why we have planned to work or rather to host this webinar. The thing is that the very important thing is just to put forth our institute is having a student branch of IEEE, and under the student branch of IEEE, we are also a part of the special interest group of affordable agriculture, which was funded by IEEE. And our college received certain grants from IEEE. And since the last 2 years, we have started working on projects related to agriculture. The thing is that we thought that India being an agricultural country, where the technology is not being brought into use to the extent what it should have been brought. Even today also, we are harping on the manual things which need to be done. But we feel that if we bring technology into agriculture, surely what our PM is expecting, that the farmers should get a double yield or they should get a double income, it will surely help the farmers to understand how they can apply the technology. And for this, I believe that we as engineers or other all the technical persons, maybe they are from the engineering or the science background, can really contribute. And I believe that today's webinar by Mr. Sarang will surely help all the participants to get an insight as to how artificial intelligence will be helpful in the agriculture sector. So with this, once again, I would like to take this opportunity to also thank the coordinator of the event, Dipali Evle madam, head of the department, Sarde madam, and Mr. Rahul Jadhav and Mr. Amit Kore for coordinating this event. So once again, thank you. And I hand over to Mr. Sarang to begin with the session. Thank you, sir.
Thank you very much, sir. Good morning to everyone.
Just a minute, sir. Thank you for your kind words, sir. Thank you for being here. I request Mr. Rahul Jadhav, sir, please join me in welcoming Mr. Sarang Nerkar and introduce him. Over to you, sir. Rahul Jadhav, sir?
Yes, sir. Yes, ma'am. I'm audible, ma'am.
Yes, please.
Yeah. So, welcome all the participants. Today we are having with us Mr. Sarang Nerkar. Mr. Sarang Nerkar is an electrical and computer engineer from University of Toronto, Canada. His research centers around wearable computing, augmented reality, artificial intelligence, and computational photography. For over 3 years, he served as a research scientist with Professor Steve Mann, who is also known as father of wearable computing, at Humanistic Intelligence Lab, University of Toronto. Based on his research, he has developed novel modular augmented reality eyeglasses, smart time-lapse cameras, and various other wearable computing, augmented reality, computational photography, and machine learning platforms. His work has resulted in various peer-reviewed research publications, trade secrets, and multiple patent filings. The focus of his work has been public sector applications of those novel technologies. His published work and products have received multiple accolades, including the Gandhian Young Technological Innovation Award presented by Honorable President of India, G. Yuva Samman, Top Innovator Award by World Bank Observatory, and Most Futuristic Award in Japan, among others. His work has exhibited at Presidential Palace in India for 6 days at Festival of Innovation and Entrepreneurship. He has been invited to present his work at various prestigious forums such as Defense Expo 2020, Lucknow, Army Commanders Conference 2020 and 2019, Delhi, Aero India 2019, Bangalore, Vivatech 2019, Paris, ACM SIGGRAPH 2018, ACM Tangible Embedded Interaction 2017. His work won Most Futuristic Award at this conference in Japan, ACM International Symposium on Wearable Computing 2017, Hawaii, Hello Tomorrow 2017, Korea, Asian Leader Conference 2017, Korea, Mobile World Congress 2017, Barcelona, Consumer Electronics Show, Las Vegas, Canadian National Exhibition 2017, Toronto, etc. He has been interviewed many times, including through Wormhole with Morgan Freeman Discovery Science Channel and Provical News China. So today we welcome Mr. Sarang Nerkar, and I will ask him to just start with the session. Over to you, sir.
Yeah. Okay. Thank you very much for the generous introduction and good morning to everyone. I would like to thank AISS All India Trust for inviting me to this session. And I would also like to thank AIC ADT Baramati for giving us this opportunity. As it was mentioned in my introduction, I'm a former research scientist from the University of Toronto, where I did research with Professor Steve Mann, who's known as the father of wearable computing. And hence, naturally, my research and overall career works in the wearable computing, augmented reality, and artificial intelligence domain. And I will talk in detail about my previous work and ongoing work towards the end of the session. We will begin the session by basically understanding what artificial intelligence is, because there's so many things going on around us where we hear artificial intelligence and we hear about it often in ways where we don't really understand what it means, except for a magical black box that suddenly solves all your problems. So it's not really quite like that. However, it is almost a magical tool that does allow you to solve a plethora of problems. And we will dive into some of the problems that are currently being solved using artificial intelligence in agriculture and how that can be developed further by the attendees here today. So I will stop my video and I will share my screen in just a second. Yes. So what is artificial intelligence? There are various definitions of what artificial intelligence is, and that is because it is such an evolving field that any definition that you come up with today is probably contradicted tomorrow, because there is almost nothing that is impossible in the field of artificial intelligence. Any problem that you think is solvable by humans, or you have a decent plan of solving it, can probably be solved by artificial intelligence, and that is really the beauty of it. I've put on the screen the definitions put out by some of the pioneering people in the artificial intelligence domain. David Marr has called artificial intelligence as the study of complex information processing problems that often have their roots in some aspect of biological information processing. The goal of the subject is to identify solvable and interesting information processing problems and solve them. Rodney Brooks says that the intelligent connection of perception to action is artificial intelligence, while Alan Turing, who of course is very famous regarding his role in the World War, is calling it actions that are indistinguishable from a human. Simply said, artificial intelligence is when a machine shows any sign of intelligence, whether remotely close to what human intelligence is, or whether completely different from human intelligence. But any sort of analytical thinking process or intelligence shown in a machine can be termed as artificial intelligence. Now, when you say artificial intelligence, it is such a vast field that we really need to break it down into simple things to understand. So, there are various ways of approaching artificial intelligence. I'm sure a lot of people have heard of convolutional neural networks and artificial neural networks and multimodal artificial intelligence. But, for the simplicity of speaking, we are going to deal with only two major approaches of artificial intelligence. And for now, we will assume that the world of artificial intelligence belongs to either one of these. One is logic and rule-based approach. This approach typically involves a machine learning a way of solving a problem based on logics and rules, where you represent processes or systems using logical rules, such similar to a flowchart per se. You create top-down rules for the computer. The computer then reasons about those rules. It understands those rules, and it then applies those rules to solve a particular problem. To give you an example, let's say a mouse had to go through a maze. The way in which the mouse typically solves this problem is by understanding whether there is any path on either of the sides, by pretty much just touching the thing and realizing whether it is a wall or whether there's a path in front. And it also tries to find out whether it is getting closer to the destination or not. Now, this sort of a rule-based approach, if there is a wall on the left, don't go on the left. If there is a wall on the right, don't go on the right. If there's a wall in front, don't go ahead, just turn back. This sort of a simple rule-based approach, which does not require very complex intelligence, but however does solve a problem that requires some sort of intelligence, is this rule and logic-based approach. In this approach, you create a very well-defined set of rules, a set of rules that typically does not have any corner cases, any cases where you don't really have a solution, such that the machine doesn't get confused, and you let the machine solve the problem. And this approach is typically used in automation of processes, right? When you have a bunch of machines working together and them relying on each other only for one or two inputs of information, you then can automate this entire chain of machines, let's say, using a logic and rule-based AI, where the AI basically decides how the process should run and applies the simple rules, doesn't really use any unique intelligence of its own. It uses intelligence developed by us humans entirely for the machine. Now, that is a more obvious way of thinking about artificial intelligence, right? If you need to solve a problem and you as a human already knew how to solve that problem, you create a rule book and you train the machine in the same way that you train a human, and that's how it learns. The more interesting bit of artificial intelligence is where you don't really give the machine any specific rules. Or by specific rules, I mean you don't give 100% of the rules, you give certain guidelines and you give certain data, and the machine somehow, almost magically, is able to find certain inferences from that and solve the problem. And this approach is typically termed as the pattern based approach. In the pattern based approach, what happens is you basically dump a lot of data, a lot of meaningful data onto the machine, such that the machine is able to see patterns. We humans are able to identify patterns amazingly, right? That is one of the beauties of our mind, that we are able to identify patterns so easily and comfortably that we term it as intuition often. When I look at a bunch of people's faces, I'm able to identify which one of them is Rohan because I have seen Rohan a bunch of times from different angles. I'm also able to recognize Rohan from the back because I've seen him so many times that whenever I see a crowd of people, I'm able to identify Rohan immediately. And that's sort of a pattern-based approach is what makes the field of artificial intelligence absolutely exciting. Because over here, you are basically providing algorithms that find patterns in data and infer rules on their own, where I don't really tell the computer how Rohan looks. I don't tell the computer, okay, this, Rohan's nose is big and his mouth is small and his ears are large. I'm not giving any information like that. I'm just giving, say, 50 images of Rohan. And the computer on its own is able to recognize what are the unique features of Rohan and how does Rohan exactly look and how to identify Rohan among a bunch of faces and how to identify a face among a particular scene that it is able to see. We will dive deeper into this example so that you get a much better and clearer idea of what exactly it is that I'm talking about. And over here, the learning from the data has a potential to improve over time because as the machine is being used, as the AI is being used, you are putting in more data as input for solving your problems. And that input is then again added to the data bank where the machine reutilizes it to learn further instincts. And this can be used for automation as well, which I said is, the obvious path for artificial intelligence. But something beautiful that it is able to do is prediction. For instance, when you look at weather prediction, you are basically looking for patterns of, these are the particular environment conditions under which a storm may brew up, or these are the particular environmental conditions, if positive, are termed as drought. Now, if I were to predict drought, the way to do that would be to look at patterns of how these environmental conditions change over time. And if I'm able to predict that pattern of how they would change over time, I would be able to say that after time t, all the conditions would be very likely to be of drought, and thus it is a drought, and I am able to predict. So these are the two broad approaches of artificial intelligence. Of course, I've ignored a whole lot of artificial intelligence approaches that are very new, like artificial general intelligence, which I'm sure you've heard of, which is sort of, like the Jarvis program in Iron Man movies, if you've seen, where Jarvis is able to comprehend everything that Iron Man or Tony Stark says and is able to perform tasks based on it. So we are ignoring artificial general intelligence for now. We are ignoring multimodal artificial intelligence where it uses multiple inputs. We are focusing purely on these two simple approaches so that we are able to get a better understanding of artificial intelligence. Now, artificial intelligence, as I said, is almost like a magical tool that is able to solve a lot of problems. But in order to understand whether this tool is useful for my particular problem or not, I need to understand what the challenges of artificial intelligence are, right? if it is intelligence, and if human intelligence is able to solve every problem out there, why is it that artificial intelligence is not able to solve all of those problems that humans currently solve? We should technically be able to replace a human if if we are so confident about this whole artificial intelligence thing. And these challenges that we are going to discuss about are key to understand whether your problem can be solved by artificial intelligence or not. And even more importantly, if you have identified a problem that can be solved using artificial intelligence, what are the precautions that you need to take while designing the artificial intelligence so that it is solving the problem efficiently and you've removed all the bottlenecks that are there in between. So the first problem that we'll discuss about is that artificial intelligence problems often involve large and complex data sets. Now, when we say large data sets, we don't mean hundreds of data points or thousands of data points. You're typically looking at thousands and thousands of data points. The more data you have, the better your artificial intelligence is what we typically say, because it is trying to look for patterns in data. Hence, it is obvious that having more data is better for your artificial intelligence. It makes your artificial intelligence better. But how much more data is enough data is a big problem that often comes up. And the second problem is, how do you get all of this data, right? When I say, let's say, images, it's difficult to get thousands and thousands of images of a particular person, but it is easy to get a few hundred images of a particular person, or even if even tens of images. Now, how is it that we adapt our artificial intelligence so that it works with the given amount of data? So that's why the large quantum and complexity of data is a crucial challenge in artificial intelligence, because it uses various kinds of data like speech, images, language, genomic data, all sorts of, any kind of data that you can think of can have artificial intelligence applied to it. And, understanding what are the right primitives to use in it, and also what typically happens in today's world, or, in general, is that your data is often very noisy, unstructured, and it has missing values. You have a lot of data, but to make that data meaningful, you need to have certain background information about that data. You need to have that data in a pristine format. It cannot be a blurry image on which you run artificial intelligence. It cannot be a blurry image which you use to train an artificial intelligence. It has to be a well-clicked image. Now, that essence of having a well-clicked image, being able to annotate everything in that image such that it is in a structured format, that overall procedure is complex, and that's why a lot of artificial intelligences fail. And that's why it is important to understand the importance of data and the importance of the complexity and quantum of data. The other point that makes artificial intelligence challenging is that it is computationally hard, which means that there's a lot of computation involved. And it isn't really solving the problem with less amount of resources. So you need to have a good trade-off between what computation numbers are you going to look at, as in how many comparisons, if, for instance, the artificial intelligence is doing, how many comparisons are you going to need? That problem is extremely large, and it needs to be taken into consideration. It is very hard to define general computational competence theories for specific tasks that say what is computed and why. Simply said, this means that what exactly is it that you want to compute needs to be defined in a very specific way. And that needs to be done with the domain knowledge, which brings me to the next point, that these algorithms typically need a lot of domain specific knowledge required. When we talk about artificial intelligence in agriculture, it's not like a computer engineer can solve an agriculture problem all by himself or herself just because they know the artificial intelligence bit of it. You need to have deep knowledge of the domain that you want to solve the problems in. For instance, over here, agriculture. You need to have enough agricultural knowledge to be able to create the artificial intelligence that is able to solve agricultural problems. This again is a huge problem that is seen in a lot of startups, which typically have mostly technical people in the team. And no real partners in the domain specific fields. This limits their capability to have domain specific knowledge and constraints. And that's why the AI does not turn out to be as intelligent, because you really need to know. For instance, if you're trying to identify diseases in a plant, you really need to know what the disease looks like yourself first before you are actually able to do anything with the artificial intelligence for it. Hence, the domain specific knowledge. So, again, out of this entire slide, the two main points that I would like you to take away are that data is absolutely, absolutely important in artificial intelligence. And the second is that you need to have domain specific knowledge. If you don't have domain specific knowledge, it is likely that your artificial intelligence is not going to be as smart, because you have no way of knowing whether it is solving things in the right way. Now that we've understood the challenges of artificial intelligence, it is important to know what are the different types of artificial intelligence. Earlier we discussed about rule-based approach and pattern-based approach, but these approaches, as I said earlier, are very broad terms. Within those approaches, there are specific types of artificial intelligence. And again, these types are, there's, hundreds, if not thousands of types of artificial intelligence today, because every person who comes up with their own unique artificial intelligence has pretty much started their own type of artificial intelligence. But broadly speaking, if you look at artificial intelligence, it can be divided among machine learning, natural language processing, expert systems, speech systems, vision systems, planning systems, and robotic systems. Out of these, the most exciting field right now, according to my personal opinion, is machine learning, specifically deep learning, because it is, we'll get deeper into that specific point. But the idea is that in machine learning, you are giving a bunch of raw data. It is a pattern-based approach for artificial intelligence. You give a bunch of data to the artificial intelligence, and it then tries to infer knowledge from it. In supervised learning, in supervised machine learning, you give certain guidelines regarding the data to the machine for it to be able to process that data. In unsupervised learning, you don't give as many guidelines about it. You just give labeled data, and the machine is able to identify patterns from it. In deep learning, and this is again why deep learning is so exciting, is that you technically don't really give any guidelines regarding the data. You're just shoving in data into the artificial intelligence, and you're almost magically getting inferences out of it. And the beauty of it is that when you give in, a few hundred data points or a few thousand data points, the machine learning performs almost as well as a human. But when you go to millions of data points, the capability of deep learning to find patterns within it is tremendous, much, much larger than human capability. And this is really where we are exceeding human capabilities. And that's why I personally think deep learning within machine learning is probably the most exciting field of artificial intelligence right now. Of course, with that, there is natural language processing, which a lot of people, I'm sure, have already experienced in their day-to-day life, which is text generation, question answering, context extraction, classification, machine translation. Machine translation, I'm sure everybody has used at this point on Google, which is Google Translate. It is able to automatically translate something that is in Marathi into something, into the same sentence in Telugu without you really defining each and every term. You are just putting in a sentence in Marathi and it gets translated to Telugu, and that's the power of artificial intelligence over here. You also deal with natural language processing a lot whenever you have OCR like applications. Whenever you used to look at PDF documents earlier, and by earlier I mean like 5 to 10 years back, you wouldn't really be able to copy the text if it wasn't typewritten. What happens today using OCR, and this I know is a feature in Adobe, is even if it isn't properly typed out text, or even if it is an image of text, the machine is able to read that text, and that is known as OCR, optical character recognition, and that is a type of natural language processing technique. There's of course expert systems which have very specialized artificial intelligence created specifically for those particular tasks. These expert systems are typically rule-based approaches where you are basically trying to teach something very specific that an expert knows in a particular field to the artificial intelligence. To give you an example, if we were to create an AI for agronomy, where the AI is able to tell you what recommendations to follow based on certain data inputs that you give to it, based on a particular specific agronomist's way of working, that would be an expert system. Again, if you go to speech, there is speech to text and text to speech. This again is being seen in a lot of application. Zoom, or sorry, not Zoom, Microsoft Teams or Google Teams, one of the video conferencing tools, actually has a live closed captioning tool, which is amazing. So for instance, when I'm speaking with you on this platform, if you were able to see subtitles of me as I speak in real time, that would be speech to text artificial intelligence, which again, you are able to see in your day-to-day life. And there's of course vision-based artificial intelligence, which is very, very popular because it is very easy for people to understand. There's a lot of tutorials on it outside on the internet, and it's something that you hear about the most. Image recognition and machine vision. Machine vision, I believe, is a course in a lot of in almost all universities even now. So vision-based artificial intelligence is when you are able to identify something based on visual traits. And of course, there's planning and robotics in artificial intelligence. We'll dive a little deeper into the most promising type of artificial intelligence. Again, this is my personal opinion that it is the most promising type of artificial intelligence, which is machine learning. In machine learning, as I said earlier, you have 3 approaches: supervised approach, unsupervised approach, and reinforcement learning based approach. In supervised approach, you're basically looking at a task driven approach where there's a particular task that needs to be done. And for that task, you've given certain data to the machine learning, and it is able to get inferences from it. It is a very well-defined approach of machine learning. A little less defined approach would be unsupervised learning, which is a data-driven approach, where you're not really relying on rules set by humans. You're relying on patterns that are observed by the machine. And that leads to a thing called clustering, which leads you to gain insights from a particular data set. And finally, there's reinforcement learning, which is an algorithm that learns to react on an environment. So the problem of a mouse going through the maze that we discussed earlier can be solved with reinforcement learning, where you basically give positive marks within the system for when the system is solving the problem in a way that you expect it to do. And whenever it starts behaving in a way that you don't expect it to do, you give it negative marks. We do this if you think about reinforcement learning, we do that with our children all the time. When you're trying to teach a child something, good habits and bad habits, when a child behaves well, you give them a chocolate, for instance. You give them some sort of a reward, and that is positive reinforcement of that rule. So if a child does X thing, and if that thing is the right thing to do, then I give the child a chocolate, which means that the next time the child does that thing and I give the chocolate again to the child develops an intelligence within himself or herself that this task is a rewarding task, and that's why I need to do it more often and thus gather as many chocolates as possible. Similarly, we teach bad habits to children where if a child does something bad, say trying to put mud in their mouth, we scold the child, we yell at the child, or we indicate to the child in a certain way that whatever it did was wrong. And that is negative reinforcement learning, where you're basically telling the system what not to do. Reinforcement learning, again, is a very exciting field and this is really the kind of field where you are able to build upon data very easily. Going back, this is a more branched out diagram of the same previous one, where you are able to see different types of artificial intelligence within these. For instance, in supervised learning, you've got classification, which is used for diagnostics, it is used for customer retention, it is used for image classification, it is used for identity fraud detection. Similarly, regression within supervised learning is used for advertising, it is used for weather forecasting, market forecasting, estimating life expectancy, and population growth prediction. Unsupervised learning has two kinds. Again, these are very broad kinds that, I'm sure have parallels to them, but we are limiting ourselves to this diagram, which is dimensionality reduction, where you're looking at big data visualization, meaningful comprehension of data, structured discovery, and feature elicitation. And of course, reinforcement learning is where you have things like game AI, skill acquisition, learning tasks, robot navigation, and real-time decisions. We will go through a detailed example of facial recognition in the machine learning format. The way in which artificial intelligence works and the way in which you design an artificial intelligence is by trying to break down a large problem into the smallest possible problem, multiple smallest possible problems, so that you are able to do the task with the least amount of computational requirement, and you are able to get an answer with less number of resources. So for instance, over here in this example, you are able to see an image with me in it. You are able to see as a human that it is a person. And if you know me, you know that person is Sarang. But a machine does not know that. So how do we train a machine to learn that this first of all is the face of a person and that face belongs to Sarang? A typical machine learning facial recognition pipeline would require you to develop a histogram of gradients, which is basically you trying to find out contours in the image. And based on that, if you see the image number 2 in the pipeline, you see these very broad contour lines that represent a face. From that, you can't tell whether it is the face of Sarang or anybody else, but you're able to tell with the features of eyes, nose, mouth, and ears that it is a human face. What the machine learning will do is it will recognize, okay, this is what a person looks like. Now, if I limit the artificial intelligence at this level, I'm able to train the system to learn what a human face looks like. So that would be one way, one branch of artificial intelligence from here. Now that we have identified how a human looks like in a simpler data format, an image is a very complex data format, while a histogram of gradients, as you can see on the screen, is a very simple form of data. So we've broken down the problem. We've identified the limited number of features that we need to identify to find the human face. We do that and we reach image number 3, which is the detection of the face. And that's why you've got a red square around my face. At this point, the machine knows what a human face looks like. But every human face looks unique. And that's why you need additional information to tell whether that face belongs to Sarang or to Rohan or to Mihir. So what you do is you could, and we are assuming over here that we are working with less amount of data. So we don't have thousands of images of Sarang to run a deep learning system where it is automatically able to identify me. So what we do is we develop these facial landmarks. In image number 4 in this pipeline, you can see these blue lines drawn on my face. And these blue lines are actually facial landmarks, to be specific, 48 specific facial landmarks that exist in everybody's face. How is my nose shaped? How are my lips shaped? How are my eyes and eyebrows shaped? And what is my overall jaw structure? These features have been identified as 48 unique features that every person has. Now, in a particular image, the machine doesn't need to know all the 48 features, but even if it is able to identify 70% of the features, and if it is able to match it with the features of Sarang, then it knows that this face belongs to Sarang. And that is how you would then break down the next problem of identifying who that is by using this sort of an approach. You then take all of this data and you train it in the deep neural network, where you've got input layers and output layers, and in the hidden layer is where all of this is going on. And you create these embeddings, which then can be utilized to run this model, this artificial intelligence machine learning model, to solve the problem of identifying who is in a particular picture. So this is how you would typically do machine learning. Now that we know what artificial intelligence is and have a decent idea of what machine learning is, we finally move on to artificial intelligence in agriculture. Artificial intelligence in agriculture has been seen to typically develop in these 3 particular domains. One is agricultural robots, usage of artificial intelligence in agricultural robots, where you're basically trying to automate various processes that human labor does, as Dr. Mane mentioned in the beginning during the introduction. The other domain where it is used quite extensively is in crop monitoring, where you're basically trying to identify different problems currently in the crop. For instance, identifying a pest in the field or identifying a disease in your crop. That is crop monitoring. And if you could see earlier, it is very similar to the facial recognition example, where we trained a machine to learn how sarang looks. Similarly, we train a machine to learn how powdery mildew looks in grapes, for instance. And finally, it is also used in predictive analytics, which is a huge part, and very relevant part of agriculture. You're able to predict various insights about crops using artificial intelligence. And these insights can go all the way from whether it is drought or not and how to tackle that, to whether the yield is going to be of a certain category, what yield is it going to be for a particular field, and what the yield estimations would be for that particular field. So in predictive analytics, the yield estimation is a major important problem in agriculture. So on your screen, you can see an example of weed control being done using artificial intelligence. On the left side, you see a small robot that has an imaging system in it and it has a spraying system in it. Now, typically, when you would spray for weed control in a field, you have a timetable of sprayings that need to be done, right? You basically say, okay, on the first day, sorry, on the 10th day after sowing, you do one spray. After 50 days of sowing, you do another spray. After 80 days of sowing, you do another spray. And finally, after 100 days of sowing, you do another spray. So you've basically given a timetable for 4 sprays that is followed throughout the entire field, regardless of whether the field has weed or not. What this robotic solution allows you to do is it identifies whether there actually is weed on your field and only apply the pesticide or other weedicide at the very specific location where that particular weed is. So with this, these companies have been able to reduce the amount of pesticide or weedicide used in the field by about 80%. So you need to think about it from a income perspective. You have reduced the costs by 80% for inputs, which are some of the most major costs that go into agriculture. And that has immediately increased the income of the farmer because he has spent less to grow the same amount of crop. So this technology actually allows you to do optimized weed control. On the right side, you see a more industrial scale version of this, where it is connected to a tractor and it is doing the same thing but row wise. So instead of directing your spray directly on the weed plant, you do it on the row which has weed presence in it. Similarly, artificial intelligence is being used extensively in harvesting, where you identify what fruit, for instance, needs to be harvested. On the left side, you see the robot, which, by the way, has soft arms, and hence it is able to extract the fruits very comfortably without damaging them. What it does is it uses image classification to identify which tomato, and in this image we are referring to tomato, which tomato is ripe and which is not. On the right side, you see what the robot sees, where you've got a bunch of tomatoes. It has done identification, like with the facial recognition example. It has first identified what a tomato looks like. This round thing is basically a tomato. That is what the machine has learned. And that's why you see a rectangle around every tomato. And the second level of artificial intelligence over here is knowing which tomato is ripe. So similar to the facial recognition example, now that we know this is a human face, who does that face belong to? Similar parallel line going on over here, where you are identifying tomatoes and then you're seeing whether that tomato is ripe or not. And the way in which you do it is you compare it with the hundreds, if not thousands of images of ripe and unripe tomatoes that you've got. And you train the machine to understand that, okay, when the tomato is green, it is not ripe. When it is red, it is ripe. If it is partially red, it is partially ripe. And that's why you can see percentages given for every tomato. The red ones are all 100%. And the green ones you can see are 14%, 22%, 53%, and so on. Because not only is the artificial intelligence able to tell you whether it is ripe or not, it is also able to give you an estimate of to what extent is it ripe. And if it is 100% ripe, the robot then protrudes towards the tomato and plucks it from the tree. And that's how you've got a harvesting system, a smart harvesting system, which is powered by artificial intelligence and enabled by robotics. Similarly, we discussed very briefly how it can be used for detection of diseases. On the left side, you see a bunch of leaves with different diseases on them. Over here, you see 38 different leaves with diseases on them. You would have thousands of images within each of these tiles so that you are able to characterize these images as a particular disease. And on the right side, you see what that results as. If there is purpleness on the leaf, it means that it has got a certain kind of disease or deficiency. And you are then able to identify which one of those is that. And basically be able to do that by using image classification. Again, the same thing that we discussed about in the facial recognition example. Now, one limitation that this has is that often different things have similar looking symptoms. For instance, if you have a particular deficiency in a plant, it would lead to, say, red coloring, reddish brown coloring. Reddish brown coloring is also happening because of something that is known as blight. So if you were to take the example of tomato has a problem of blight, which is a disease that is caused due to scorching of sun. And sorry, not scorching of sun, it is a disease, and scorching of sun is another problem that leads to a similar symptom. Now you've got three different problems that lead to more or less similar symptoms, where your artificial intelligence fails because it is unable to tell whether this redness on the leaf or brownness on the leaf is because of is because of blight, whether it is because of scorching, or whether it is because of a deficiency. Over here, you need to understand the importance of data, as we mentioned earlier, because the more detailed and the more clear your data would be, the better your performance in this sort of a confusing scenario. Because if you were to mention that if the red coloring or the brownness appears at the edges, and that is the symptom for the deficiency, while for blight it is yellow, it is brown spots surrounded by a yellow ring, and for scorching it is directly brown spots. If you were able to identify these different domain specific nuances in the data, and you were able to train the artificial intelligence with those nuances and domain specific knowledge, you would have a much better performing artificial intelligence. Hence, importance on domain specific knowledge and importance on amount of data. Because to identify these brown spots, you would need hundreds of images in each of those categories, namely scorching, blight, and deficiency, to be able to uniquely identify them from each other. This is a domain that needs a lot more research in artificial intelligence in agriculture. And that is something that our company, Sapient Technology, actually works on. Finally, I'm also going to talk about usage of drones in artificial intelligence. Drone is a very complex machine that uses artificial intelligence in various ways, all the way from flying of the drone. You might have heard of drones having an auto path planning technology in it, where the drone automatically goes in a grid while flying and collects the data without necessarily having a pilot do that. That in itself is artificial intelligence. In agriculture, drones are being used for smart pesticide spraying, what we saw earlier with the weed control technologies. Over here, you're doing more or less the same thing, but with a drone instead of a robot. And on the right side, you see the kind of imaging that the drone does. Using various sensors, it is able to identify where the problems are. And by identifying those specific problems, it is able to deliver the right solution in a limited quantity in those particular spaces. Hence, being able to identify what the problem is, where it is, and how much the intensity is, so that you're optimizing the input. The input optimization that I keep mentioning is extremely crucial, as we mentioned earlier, for farmers, because that directly affects their income. To double a farmer's income, you don't necessarily have to increase the productivity of his farm. You can also reduce the cost per acre of cultivation and directly lead to a cost savings for the farmer, which leads to increased income. So drones allow you to do quite a lot of that. These are a few examples of artificial intelligence in agriculture. I can, of course, not go through all of it, but the exercise so far was to give you a decent idea of what artificial intelligence is, what are its capabilities, what are its limitations, and give you a few examples of how it is being utilized in agriculture so that you are able to identify similar problems like smart spraying or disease detection or weed management or harvesting so that you know how to create an artificial intelligence to solve these specific problems. Now, when you're bringing the technology here in India, again, something that Dr. Mane spoke about earlier is that we were expecting a lot of artificial intelligence in the domain of agriculture by now. But in reality, it hasn't kicked off as much. And the reason for that is you are not able to, deliver it to the farmers in the right way. It's not always that great technologies end up being delivered to the end user because there are various factors that are involved. And these factors, specifically to India, are affordability. It has to be an affordable solution. This is where drones so far haven't been able to perform that well, especially from a purchasing mode, because the drone itself costs you a few lakh rupees. And to fly the drone, you need a pilot, which is again, at least a few thousand rupees per month salary going over there. So overall, it turns out to be not the most cost effective solution, even though it is helping you reduce the input costs. A lot of farmers that I have interacted with who have tried drones have actually told us that the cost reduction by optimization of inputs is actually more than compensated by the cost of actually operating the drone. So it doesn't, as a package deal, it doesn't turn out to be very affordable for the farmers. Similarly, it has to be scalable. Let's say you are able to do if you're able to develop a particular solution that is amazing in terms of affordability, in terms of performance, but is not scalable. If you create a robot that, let's say you're creating a robot and you've created the robot such that it is solving all the problems of the farmer, you're able to, deliver it to them in a low cost manner. But it also should be scalable because you've got millions, hundreds of millions of farmers in India, and to be able to reach to all of them, for all of them to be able to take benefit of your technology, the technology has to be scalable, which means that you need to be able to think of mass production and large scale production right while designing a particular solution, because there's no point in designing a solution that you can make only 100 of, because there's a few 100 million to serve over here. The solution needs to be geared towards Indian people and the Indian market, which might seem very obvious to us because we're talking about agriculture in India. But unfortunately, that is not the case, because often what happens is we try to retrofit solutions that are developed for Western countries in the Indian scenario. For instance, the weed control solution that we saw earlier, there was one which was a smaller system and one that was a larger system. The larger system, if tried to retrofit in India, doesn't work that well because it is not geared towards Indian farmers. Indian farmers have small landholding typically. And that's why automated solution that runs with a tractor is not the most feasible one. That's why it has to be adapted for the Indian market and Indian needs. And finally, it has to be need-based rather than want-based. to bring the technology in India, you really need to be able to convince someone that they absolutely need this technology. To be able to convince someone in, especially in a country like India, you need to be able to gear it for them such that they feel the need to buy your technology. It shouldn't be something that adds to their, comfort, or rather, not comfort. Comfort is not the right word. It shouldn't be a desire-based thing. For instance, in terms of phones, you've got a regular Samsung A series phone, which costs you about 15,000 rupees. And you've got an iPhone that now costs, above a lakh. The need of India really is a low cost phone because not everybody can afford an iPhone. And that's why that sort of a need based approach needs to be taken for a technology like artificial intelligence. Ma'am, we are actually done with the artificial intelligence in agriculture bit. I would like to take a few minutes to talk about my specific contribution to the field of artificial intelligence. Is that fine? We have time?
No problem, sir. You can proceed.
All right. So, why is it that I am talking to you about artificial intelligence? Because I have, in my limited capacity, tried to make a contribution to the field of artificial intelligence, and that is through humanistic intelligence, which I developed with my former mentor, Professor Steve Mann. Humanistic intelligence is a novel human-computer interaction platform that we've created that uses human and machine in a closed feedback loop system, where the machine provides inputs to the human provides inputs to the machine, and they both work cohesively together as if one single system. And that is one of the reasons why my former mentor, Professor Steve Mann, also known as the father of wearable computing, is also known as the world's first cyborg, because he has been wearing an augmented reality headset on his head for the past 40 years. And the way in which this platform works is it knows that there are limitations for artificial intelligence, right? We discussed about the challenges of artificial intelligence, but we as humans never face those challenges because we are really good at certain things just because of our instincts. So why not use those instincts in the same platform and create it such that the machine is able to benefit from the human as well? Why is it that the human only has to benefit from the machine? And that is what led to the concept of humanistic intelligence. We all have senses and effectors, right? A human has senses. My eyes, my ears, my nose are my senses. And I have effectors, which is my arms with which I can push things, I can pull things. I have my legs with which I can go from place A to place B. And these are the two sets of inputs and outputs that I have as a human. A machine similarly has sensors like cameras, microphones that sense things for the machine, that give information about the outside world to the machine. And there are actuators like a robotic arm, a motor, a valve, things like that, that the machine can actually act upon based on the information that it has gained from the sensors. What we do in humanistic intelligence is that the machine, based on the unique capability of its sensors, is able to provide the human with inputs that the human senses cannot provide. Hence, you're providing new inputs from the sensors. And you now have a machine, human system, that has the benefits of a human as well as a machine. This whole concept is based around the idea of valence, which is the capability of sensing. A human is able to sense, but in certain things, but it is not able to sense certain other things, for which we generally create sensors. For instance, I as a human am able to see in the visible spectrum, but I'm not able to see in X-ray spectrum. And that's why we have X-ray sensors that are able to image in the X-ray part of the spectra. But those sensors aren't able to see what I as a human am seeing. So when we fuse both of these systems, you now have a unique system where you've got a human brain, you've got the capability of seeing in the visual spectrum because that's the natural instinct of humans, and you're also able to see in the X-ray domain, hence giving you a capability that humans didn't have earlier and that machine also didn't have earlier. That's why you've got a benefit on both the sides. Now, this, it's a very complex ideology of humanistic intelligence. I know a lot of you are probably confused as to what these sensors and effectors and actuators are. But to put it simply, when you look at a person, or let's say when you look at a deceased plant, a farmer is able to identify what that deceased plant has just based on his instinct. Now, that farmer might be confused among 2 or 3 things that he suspects are the disease. But this entire process of going from a million options of what that disease could be to just 3 possible options are all based on the intuition of the farmer. Now, when the farmer sees such a thing with his intuition, he's already solved about 70% of the problem. The remaining 30% is where the farmer is uncertain, and that's where artificial intelligence can come in. So in a humanistic intelligence domain, you wouldn't get the artificial intelligence to solve 100% of the problem. You would immediately use the instincts of the human to solve it to a certain extent, that within a few microseconds, because that's the capability of humans, and then utilize that input from the human senses provided to the machine with inputs from the machine sensors, and actually get a much, much better and much more refined output that has accuracies that are much larger than your traditional artificial intelligence system. And more importantly, it has the capability of not having false positives, which is a huge problem in artificial intelligence. And artificial intelligence, when it looks at my face, can call me Rohan because it does not have enough information on Sarang. It just tries to match you in some box, in some category that we have already defined. While using a humanistic intelligence approach, you already have a human that is giving in the inputs. So if the person in the humanistic intelligence system already knows Rohan and looks at me through this humanistic intelligence platform, is able to tell within a microsecond that I am not Rohan, because he knows who Rohan is. So he knows for sure that this isn't Rohan. So the moment the artificial intelligence prompts that this might be Rohan, the user already knows that it is not true. And that's why you have eliminated the possibility of wrong identification, which is what is known as false positives. Now that we are done with some basic information about humanistic intelligence, let me show you by example what humanistic intelligence really means. An example of humanistic intelligence that we have developed is providing you capability that you earlier did not have. So what we did is we created an imaging system that is able to visualize things much better than either humans or machines. For instance, when you do welding, you have to wear welding mask because the direct light from the welding machine can damage your eyes. It is too bright. It is way too bright for your eyes to be able to sense. It is way too bright for a regular camera to be able to sense. So we came up with this technology called high dynamic range imaging, which actually allows you to see welding very clearly. I won't get into details of that because that is a completely different innovation when compared to artificial intelligence. But just say for now, we have created a unique sensing mechanism that allows you to look at things with the kind of clarity that you have on the left side image, which is the clearest image of welding ever taken in human history. Now that you are able to see welding much better than a human was ever able to, hence already going beyond the capability of a human, you are now also able to analyze whatever you're seeing. So on the screen, you will now see a video which is analyzing the welding in real time. So the green circle means that the welding is going right. When the circle goes red, it means that it's going wrong. And it is able to apply this artificial intelligence only because we have created this humanistic intelligence high dynamic range imaging platform. If it wasn't for the imaging platform, you would never be able to apply this artificial intelligence. And this actually is the unique way in which our company works. We don't create technology, artificial intelligence just on its own. We create artificial intelligence based on unique that is
Hello.
Yes.
Yes, Saran sir, there is some noise.
I beg your pardon?
There is some noise. You are not audible properly.
Okay, can you hear me better now?
Yeah.
I think it is because the video was playing. So I'll avoid videos where possible.
No problem. Yeah, thank you.
Another example of humanistic intelligence is the usage of augmented reality, which is what you see on your screen. It is a pair of eyeglasses that was my invention that is used for various tasks. And these tasks are actually performed by the human, which is me, with the assistance of the artificial intelligence. The benefit over here, and this again is something where the ethics of artificial intelligence lies, is that you are able to create a technology that can replace, humans. If you create a spraying mechanism which is so efficient that you're able to. Sorry, am I audible? Hello?
Sir.
Hello?
Yes, sir, you are audible.
Yeah. So, artificial intelligence is also a very dangerous thing if you think about it, because it has the capability of replacing humans. When you create an artificial intelligence enabled robot that is able to do spraying of inputs, that is able to do management of the field by detecting diseases and pests, that is also able to do harvesting, then why is it that you need the farmer at all? The artificial intelligence enabled system is doing the entire thing, and we just have to sit and eat the produce that comes out of it. This is a big issue from an ethics standpoint, as to if we start replacing every task that humans do with an artificial intelligence system, then what will humans do? And this is especially important in a sensitive field like agriculture, where you have a huge part of the population, right? Like about 50% of India's population, if not more, is directly or indirectly dependent on agriculture for employment. If you start replacing the jobs of all these people with robots and artificial intelligence, all of these people will go jobless. So, and over a period of time, you will have the next generations learning how to create artificial intelligence and hence gaining new employment opportunities. But what is often ignored in artificial intelligence ethics discussions is what will happen to the workforce of today. What will happen to the people who are working today, who are earning their families' income today using their skills, which are soon to be replaced by artificial intelligence. And that's where the concept of humanistic intelligence really helps, because humanistic intelligence never really removes the human from the loop. You are increasing the capability of a human to do multiple things more efficiently. So you would need, say, only 3 farm laborers instead of 10, but you would have 3 farm laborers who are much more skilled than the 10 farm laborers that you had earlier, much more capable than the 10 farm laborers that you had earlier. And those remaining 7 farm laborers who are now rendered jobless because of this technology can be utilized to create the domain specific knowledge for that particular system. Hence, creating a balance between human and machine, which, again, in my opinion, is being lost in the entire artificial intelligence approach. This is another example of humanistic intelligence where you are actually sensing a sensor. There's a hidden microphone inside this soft toy. And this device that I've invented actually is able to detect the waves coming out of that. And it uses artificial intelligence to sift out noise from this. And that's why you can see the wave being so clear without any noise in it. This was again utilized to create the world's first augmented reality visualization of gravitational waves. This data is from the same gravitational wave discovery that won the Nobel Prize in Physics in 2016. And our contribution to that was being able to clean up the data for them using our artificial intelligence and humanistic intelligence techniques. Finally, we've worked an artificial intelligence system that assists visually impaired and cognitively impaired people in their day-to-day life. And this is what we won the Gandhian Technological Innovation Award from the Honorable President for. I'm going to skip this video as well. And that would be it from my side, madam. If there are any questions, I will gladly take the questions. Thank you.
Thank you for your stimulating speech. Please accept our sincere appreciation for the outstanding presentation you made. It's our privilege that our member of managing committee, Nikhil Kansu, has also joined us. A warm welcome to sir. Thank you for joining us for today's webinar. I request Mr. Rahul Jadal sir to proceed with question and answer session.
Hello, sir.
Yes.
Sir,
Yes.
there are a few questions from participants. So I will just read it out. So the first question is from Hauzi Pujawar. In these growing types of AI and IoT, how important does the need of knowledge of analytics play to make the most out of these new technologies as a student?
I'm sorry, sir. Could you please repeat the question?
The question is, in these growing types of AI and IoT, how important does the need or knowledge of analytics play?
So the knowledge of analytics is very important actually, because, as I said earlier, the artificial intelligence is at the end of the day created by a human. So in order for your artificial intelligence to be able to do analytics really well, you need a human who's able to do the same analytics, even better than the artificial intelligence, so that the artificial intelligence learns from the human and is able to replicate that for millions and millions of people. So here's a big problem in agriculture that I can relate to in regards to this. What your question basically asks is, is an analytics professional even relevant in this given time? And the answer is yes, because like in agriculture, to understand the problems in your field, you need an expert agronomist to come to your field and do the analysis of your field. Now, that expert agronomist, first of all, there are very few expert agronomists available, right? You have much more number of farmers when compared to the number of agronomists. And that's why there's a supply and demand problem, because there's, thousands of farmers approaching a single agronomist for their services, which the agronomist physically cannot provide. Now, in order to provide such a service, what can be done is that agronomist can work with a technology team, create an artificial intelligence for the basic of his or her services, and utilize that artificial intelligence to give, say, 40% of his overall package of services to everyone just by using their smartphone. So yes, it is important for you to understand how analytics works, so that you are able to teach the artificial intelligence that, because the artificial intelligence needs to know about this from somewhere, right? It might be able to identify patterns, but what does that pattern mean? That knowledge it gains from the human. So it is absolutely important to work in these domains so that you are able to enhance the overall capability of artificial intelligence. I hope that answered the question.
Thank you, sir. So next question is from Ms. Kirti Chintawai. She has done a project in AgriBot, a prototype which is having DTH11 and soil moisture sensors. So she is asking how she can interface it with AI.
Okay, so you developed soil moisture sensors, right?
Yeah,
So
soil
we'll
moisture
just
and DTH.
stick to the example of soil moisture sensors for simplicity. Again, I don't know much about your solution here, but I'm just going to give my 2 cents of advice so that you have a direction to work in. And this is how people are using artificial intelligence with soil moisture sensors. Is that if you were to place a soil moisture sensor for, I'm assuming yours is a IoT based soil moisture sensor that in real time is able to give information, right? So there's only one location where you can put one of these sensors. And let's say in a 1 acre field, you've put say 5 sensors at most, right? Which is already a lot more than what is required, I think. So you've got less number of sensors, but you've got a very, very vast, number of fields that you need to cover and a very vast area that you need to cover. So let's say if this was the overall map where you've got sensors in some fields over here, you've got sensors in some fields over here, and you've got sensors in some fields over here. There are certain regions in the map where you don't have any soil moisture readings coming in from, which means that if you were to create a soil moisture map, right, the entire map, a map doesn't have only certain parts in it, it has the entire thing in it. So for you to be able to estimate what soil moisture details are in these regions, you might use techniques of artificial intelligence based interpolation. So given remaining conditions in that overall map, let's say the environmental conditions, you're able to somehow correlate with your soil moisture sensors along with satellite imagery so that they all conform to one particular soil moisture reading. If you're able to do something like that, you are now able to estimate soil moisture analytics in these regions where you did not have data and extrapolate or interpolate data so that you are able to get more information than you already have. So you're using things like environment data, which is already available to you through IMD. You're using satellite images, which again are more or less available to you at a decent frequency. And you use them to gain insights on if there was soil moisture sensors that I've developed in this region. Based on the satellite imagery and the environmental data, what would the readings of those sensors be? So, those are different ways in which you can utilize it. Again, if you were to automate, say, a pump, right? I'm assuming that is the direction in which you want to go. You want to automate the irrigation system of a farm based on the soil moisture sensors. You can create an artificial intelligence that automatically regulates the pump with the help of that. So if there is X amount of soil moisture, then you don't need the pump to be active. If it is less than X, then you need the soil pump to be active. Now, if you were to go one step beyond that, you can also start looking at, okay, should the pump be 10% open? Should it be 20% operational? Should it be 100% operational? Things like that are where you can utilize artificial intelligence to enhance your solution.
Thank you, sir. So next question. Hello.
Yes, please go ahead.
Yes, sir. Next question is from Professor Varsha Patil, ma'am. What is precision agriculture and how it is different from traditional?
Precision agriculture and how it is different from traditional.
Yes.
if you remember the example of weed control and also the example of drones that I used in the presentation, that is more or less what you call precision agriculture. Again, these are keywords that are thrown around quite a lot. That have very broad meaning, right? Like, what is precision agriculture? Precision agriculture can go all the way from having a lot of location based information about your field to actually being able to diagnose disease on a particular leaf which has nothing to do with your overall field in general. So precision agriculture again isn't necessarily related to artificial intelligence either. It could be a human looking at precise data, precise location specific data to gain insights about the field. So precision agriculture does use artificial intelligence quite a lot, but it is not necessarily a subset of artificial intelligence per se. So again, to somewhat try and answer your question, in precision agriculture, you're trying to use sensors to get more location specific information about the field, which otherwise in a traditional farming sense you wouldn't, right? Like in the drone example, you're spraying only where the drone requires you to spray, right? Wherever there is disease prevalence or there is pest prevalence. In a traditional agriculture format, you would go ahead and spray the entire field, regardless of whether the entire field needs it or not. I hope that answered your question. I know it's a little vague answer, but precision agriculture is such a vast field that you could do an entire webinar just on that.
Thank you, sir. So next one is from Akshay Kalaskar. I am thankful of AI is being great invention in agriculture field, but technology is very costly. So is it affordable to every farmer? If not, then what is the another solution?
Well, so in terms of is there another solution? Well, there is another solution. Agriculture has been going on without artificial intelligence for thousands of years. So you could continue doing agriculture in the same way, but again, it is not optimized in terms of costs. It is not optimized in terms of chemical usage. So there is a great incentive to use artificial intelligence in agriculture, just from the optimization perspective. Is it affordable? Now that really depends, right? If you looked at the tractor solution, I'm sure that one is in tens of lakhs. While the drone based solution is in a few lakhs, say 10 lakhs or less than that. And it could also be something as simple as just a smartphone based artificial intelligence, which could be a free app. So the affordability of it really depends on what mode it is being delivered in. Of course, with a more expensive solution, you get more capabilities, right? With a drone, you're able to fly it around and you're able to do it, much faster than humans. With the tractor-like solution, you're able to do, instead of say 1 acre a day, you're able to do 20 acres a day because it is such a large system. So affordability, I can't really talk about. Sorry, I can't really talk about affordability from an objective sense about artificial intelligence. I would rather say that it is up to you to create an affordable solution. So, it's all up to you really, because you get to design the system, right? You might choose to use less expensive sensors so that you have less information, but you can try to enhance your artificial intelligence such that it works on the less information from the lower cost sensor. So it is all about trade-offs, and that's one of the major reasons why not every artificial intelligence company has succeeded in a domain like agriculture, and that's because it's just so difficult to figure out that cost versus benefit correlation. I hope that answered your question.
Yeah, thank you, sir. So we have one more question. from Ashish Verma. So except deep learning, any other method to solve crop disease identification? It's very tedious to identify type of disease from the images.
I agree. So artificial intelligence can either be used to, directly look at a particular image and be able to identify a disease. Or you could also be trying to do prediction of the disease, right? For instance, to give you an example of grape farmers, the way in which they do it. If there is rain today, the grape farmer knows that within the next 2 weeks, there's going to be powdery mildew in his field. Powdery mildew, downy mildew, it is going to be in his field. He just knows that, the farmer. How does the farmer know that? Based on the years and years of experience, the farmer knows that if it has rained today, 2 weeks' time is what it takes for, downy mildew to appear. Now, the way in which you could create an easy solution is to predict rain. And if you're able to predict rain, if you're able to predict rain 5 days in advance, you've got 5 days in advance of that, and you've got 10 days advance notice for downy mildew, because it takes about a couple of weeks for it to be present on the field. So you've got a head start of almost 15 to 20 days than when the downy mildew actually appears on the field. So, prediction is a great replacement for image classification. And prediction, is a very cost-effective solution as well. So that actually answers the previous question, because predictive solutions need you to have sensors, but not very expensive sensors, and not in a very vast network. So, that again, it's a very open-ended question. But if you were trying to do disease identification or pest identification, perhaps prediction would be a better way to go if you don't want to go for image classification. By the way, prediction is also often a lot more accurate than image classification, because image classification, again, because of the limited amount of data that we have, you're not able to create a super accurate solution. And that might work the other way as well, like in terms of prediction, your prediction is always a probability. So again, there are pluses and minuses, because I don't know if you noticed in my overall humanistic intelligence approach, my personal preference is always to create a system that has best of both the worlds. So I would in fact create something that is half image classification and half prediction, and utilize both of them to support each other rather than try to contest them against each other.
Thank you, sir. Now, last two questions. First is from Ashwani Paitankar. Can we measure the dimensions of the tool or any product by using AI?
Yes, you can. Simple answer, yes, you can. How you can do it? By using computer vision techniques. If you just Google, object dimension measurement using AI, like I'm sure you'll find a lot of tutorials.
Thank you, sir. The last question. In most of the cases, no two environments will be exactly alike. So how this challenge can be tackled while developing a unique or generic solution?
Okay. The question was a little confusing. I'll tell you what I understood from the question. I think what the person is trying to ask is the agroclimatic environment and overall crop growth environment in Israel and India are very different. So how is it that we create a solution for Israel? Because we know it is a more technologically advanced agricultural society. So say there is a solution in Israel, how do we use it in India? Right? I believe that is the nature of the question. And that is actually, that was in my slides. It has to be a solution catered for India. You cannot have something that is 100% exactly the same being used in Israel as well as India, because the two regions are just so vast. The way in which grapes grow in Israel versus the way in which grapes grow over here is very different. Uh, Forget about the ways of farming, even the overall environment and the climate is just so different that I personally believe you have to create a new system over here. However, what you can utilize is a technique called transfer learning, where you use the learning capability of that artificial intelligence in Israel, and you adapt that learning capability to learn the same things about the Indian environment, but with less amount of data. So you can reduce the amount of work that you need to do if it is already done somewhere else, and you can benefit from that learning. But in my personal opinion, I don't think it is a replacement of the work being done over here. If you are trying to do it in two different regions, it has to be location specific. In my personal opinion, yeah, it's open to debate.
Yeah, thank you very much, sir. Now I would like to hand over to our student coordinator, Mr. Yash Gowde, to proceed for vote of thanks.
Thank you so much, Rahul sir. A very good afternoon to one and all. On behalf of All India Sri Shivaji Memorial Society's Institute of Information Technology, I, Yash Gowde, feel the privilege to give the vote of thanks to our dignitaries on the web and off the web. Firstly, I would like to thank to our speaker, Mr. Sarang Nerkar sir, for sparing his valuable time guiding us over the webinar and letting us know the importance of artificial intelligence in day-to-day life and as well as in agriculture. I thank our honorary secretary, Sri Maloji Raje Chhatrapati, for his constant support. Sri Nikhil Kanse sir, member, managing committee, for all-time guidance whenever we need it. I would like to thank our dynamic principal, Dr. P.B. Mane, for providing us an opportunity to conduct this webinar. Also, I would like to thank our HOD ma'am, Dr. MP Sarde, for her constant support. On behalf of entire AISSMS team, I would like to thank Mrs. Jaya Tiwari ma'am and her team for organizing this webinar. I would now request HOD ma'am to speak a few words.
Hello, ma'am. Hello. Kore sir. Hello, Kore sir. Kore sir.
Hello, Deepali.
Yes, you are audible, ma'am. You can proceed. Please.
Okay. Yeah. Good afternoon, all. And thank you so much, Sarang sir, for accepting our invitation as a speaker to the said seminar. Hearty congratulations to you for your various achievements, and really proud of you that really one of our Indian is working overseas, and that is really a crown in among our all Indians. I would just like to brief you about how we have started focusing on agriculture based project. I think my sound is echoing. Just a minute. My sound is echoing, madam. Deepa.
Yes, ma'am, but it's audible.
Hello, Deepali madam.
Yes, ma'am, but it's audible.
Is it clear or it is echoing?
It is echoing, but it is audible, ma'am.
Now, how is the sound now?
Now
Is it clear?
ma'am.
Yes, ma'am. Now it's clear.
Okay, sir. So we are focusing on technology in agriculture since last 2 years, and the reason behind is that our Pune University, they have introduced one subject related with the technology in agriculture or electronics in agriculture since last 2 years, and hence our focus is totally diverted towards this technology. And in turn, we have done an MOU, Memorandum of Understanding, with Krishi Vigyan Kendra Baramati. You might have heard about it. And we have visited over there, And really the first time we have seen what are the advancement in technology is going on. Actually we came to know through the newspaper and of course the television news, but actually we could see over there. And that's what we have organized their boot camp, their seminar for our final year students, and our students are really got inspired and they are doing the projects. They have done very good projects like spraying pesticide spraying using the drone, then how we can increase the life of the fruit, the grass cutter, and many more projects they have done. Major issue is over here is the cost issue. There are two issues what I can interpret. The cost is, I think, the major issue. Another issue is all this technology, many more researchers is going on, but it is already they are going on here in the urban area, whereas this technology is not able to reach to the end person where it is required and where the farmer is poor. So as far as uh, how we can do the cost, how we can curtail the cost of all these technologies so that a normal farmer can use this one. So this is what my question. uh, as far as the Israel, actually I was supposed to talk on that because we all of us know that India is really blessed with the all natural resources, whereas the reverse is the situation in Israel. But still the way the farming is done over there, okay, it is really creditable. And is it possible for us to use such type of technology in India? This is what my second question, of course with certain modifications. This is what my question, sir. Over to you, sir. Hello.
Yeah. Are you able to hear me?
Yes, now I can hear you.
So yes, ma'am, absolutely. The cost effectiveness is definitely something that we try to work on with my own company. InnoSapient Technologies, as I mentioned earlier, we try to use technologies like wearable computing, augmented reality, and artificial intelligence in a cost-effective manner for farmers in India. And the cost effectiveness, it has to be an overall cost effectiveness of the package is what I believe. It is very difficult to think about it from a individual cost perspective. Like for instance, if you think about it, a few lakh rupees sounds like a huge cost, but the cost of production for grapes itself, if you look at it, is close to 1 lakh per acre. So it's not like farmers are not spending lakhs of rupees. So from an objective cost perspective, it probably doesn't make sense. But if you think about it from input reduction costs and overall, output maximization costs,
Benefit.
The key is to make the system as low cost as possible. And even more than that, the net profit for the farmer has to be demonstrable. That I think is the biggest issue right now, because a lot of technologies talk about, these are the benefits, so many benefits. But we are not able to show the farmer that if you buy my thing today, you are going to have a return of that cost with additional profits in a very short period of time. That period of recovering that cost, if we are able to minimize, that's the best case scenario. With our company, we have developed a model such that within the first harvest itself, the farmer is not only able to recover the costs of the devices, but also able to get additional profits.
Okay.
So we are trying to work on it from an overall package perspective. But like that is the kind of approach that everybody, I think, needs to take. Because if you think about it, the moment a farmer in India hears lakhs of rupees, he's already, quite taken aback. So it has to be explained to them in a right way as well. And the idea of a shared utility, like for instance tractors. A few decades ago, you wouldn't see every farmer with a tractor. But today, you see that almost every farmer is utilizing a tractor, even if they don't if they haven't purchased it. So they are able to lease it from leasing companies. So there will be models like that come up to reduce the overall cost of operations for the farmer rather than cost of procurement by the farmer for these things. Secondly, ma'am, you asked about Israel and
Yes,
can we
yes,
use
sir.
technologies like that? And actually, you answered the question in your own statement earlier, where if you go and see KVK Baramati, it is equally good, if not better, than some technologies that you see in Israel. So they have actually demonstrated with their demo plots how certain unique technologies, whether from Netherlands or from Israel, that can be brought to India, and what unique thing Agricultural Development Trust Baramati does is that they don't just bring a technology to India. They bring the technology, they adapt it for the Indian market, and then they
Okay,
deliver to the farmers. So
okay,
that
okay,
adaptation, I think, is key.
okay.
Yes.
Acha. Another point I would like to say that now this was a webinar which we have organized for 1 hour, 1.5 hours. So, is it possible to organize the faculty development program where the students and the faculties those are interested in the agriculture area, technology in agriculture area, they can attend, and in depth we can cover, say for 4 days or 5 days. So, is it possible to do?
Absolutely, ma'am. In fact, we already do faculty development programs that we operate, not just in agriculture, actually, in the overall, technology domain, all the way from quantum computing to wearable computing, augmented reality, IoT, artificial intelligence, and humanistic intelligence. So that definitely we can develop a, catered program for your institution. That
Okay.
definitely can be done.
Yes, sir. Thank you so much. Nice to know about the artificial intelligence. We are studying since years and years, but the humanistic intelligence, really, it's nice to know that machine is working along with the human being. It's not like artificial intelligence where only the machine is working.
Absolutely.
So I think we need to focus on humanistic intelligence also, so that we can suggest our university whether we can introduce this subject as the subject revision is going on every year. So this is a very good idea from you. So
Definitely,
this,
ma'am. I would, I try to promote humanistic intelligence as much as possible.
yeah,
One, because it is, my invention, and secondly, because there is a active debate about whether artificial intelligence should be used or not, and that is because, again, the thing that I mentioned earlier is if all the human jobs are taken up by artificial intelligence, what will we do?
yes,
It's a huge problem, especially in a country like India,
yes,
where you've got a huge part of the population just in agriculture, about 500 million people relying on it, and then going jobless is something that that might be profitable for the
yes,
farmers with landholding, but it will be disastrous for the country overall. And that problem is addressed by humanistic intelligence. So,
yes. That's
uh,
why it is really very good, and AI is going dominant over everywhere. If you will see the driverless vehicles, or even AI is introduced in military also, that is highly dangerous. But still, I don't know why so much research is going on the same thing to uh, deploy on robots everywhere for every work which the human can do. That's really a threatening for a human being in future also. Thank you so much, sir, for your time, and looking forward to you for the another faculty development program if you can arrange in nearby. of course, Dipali Ore madam, she will be in a touch with you. Thank you so much for our management member, Sri Nikhil Kanse sir, for his he is also attending the same program, and actually he is the reason why we could do the MOU with the Krishi Vigyan Kendra Baramati. Thank you, sir. Thank you so much. Over to you, Dipali ma'am.
Conclude the session. Yes.
Yes,
Thank you so
ma'am.
much, ma'am. Thank you so much, ma'am. Finally, last but not the least, I would thank you, Dr. Professor Deepali Evle, ma'am, Professor Rahul Jadhav, sir, and our technical coordinator, Professor Amit Kore, sir, and Professor Chetan Iyer, sir, for their coordination. Thank you so much, Sarang, sir, for sparing your time with us. Thank you all. We conclude this session now.
Thank you
Thank
very
you.
much. Great pleasure.
Sarang sir, you can do the session.
Yeah, I would actually like to thank AISSMS and AICADT Baramati for giving us this opportunity and creating this dialogue about technologies such as artificial intelligence. We look forward to coming up with a faculty development program so that the penetration of this can be deeper in the overall education domain in India. And yeah, thank you again for this great opportunity. It was great talking to everyone over here, and it's great to see people value technologies like artificial intelligence in domains like agriculture, while still having the sensitivity of not replacing every human job by artificial intelligence. I really appreciate that, ma'am, and thank you again for this opportunity.
Thank you so much, sir. We'd like to see you anytime if you are in Pune or in Baramati. We'd like you to visit our college also. So I hope we can see you in
Definitely.
Pune.
Definitely.
Yes, sir. Thank you.
Thank you very much. Have a great day.
Hello. Hello.